let's just start with these do it questions. They're pretty easy, okay? Kind of like just stretch your brain out before vacation here. Evaluate x squared when x equals 7, and the whole class said?
49.
49, nicely done. Okay, we know that because if I plug in the 7 for the input, I get 7 squared, which is 7 times 7, which is 49. Okay. Evaluate the square root of x when x is 81.
9.
What do we get there? 9, everybody, right? Because this is the square root of 81, which is 9. I have a question. What would this be?
Negative 9.
Negative 9. We all agree? Because that means negate the square root. What would this be?
Plus or minus negative.
Plus or minus, not just plus or minus 9. Okay. We never get a negative out of a square root. What would this have been?
Imaginary.
Imaginary, right? Specifically, it would be a number called 9i. Right. Okay, next. Number 3, evaluate x cubed when x equals 5.
125.
125, everybody said, right? Right? Because that's 5 to the third, which is 5 times 5 times 5, not 5 times 3, which is 125. And then the cube root of 27?
3.
It is 3. Now, I just want to show you that your calculator will do cube roots for you. If you go to, let me just see very quickly on
Math.
Brian's side of this. I think it's math and then,
4.
is it math 4? Let me check.
Yeah.
Math 4. Okay, good. So if you first put in the 27, and then you go to math 4, it'll do the cube root of that. Okay? And a little later in the year, we'll show you how to do 4th roots and 5th roots and so on and so forth. It's not complicated, but we're not ready for it quite yet. We have to learn a little more about exponents first. Okay, now, are there any questions on what we just discussed? All right, so let's do, this is the point where I would really appreciate it if you didn't copy anything down, if you just kind of looked up and watched and see how things go. All right. Let's talk for a moment about where the vertex of these parabolas would be and other features that we can get by looking at the equations in vertex form. Look at the first one. Tell me what you can notice there, something, a conclusion to be drawn. Spencer?
The vertex is 5, 1.
The vertex is 5, 1. Very good. I know the vertex is 5, 1 because in general, with any parabola, in vertex form, it's y equals a times x minus h squared plus k. All right, nobody should be writing right now. Nobody should be doing anything. I want to review this. I want everybody's focus here. HK, H stands for horizontal shift, K stands for vertical shift. H in the parentheses is always reversed from what it should be. So this says -5, so therefore the horizontal shift is 5 to the right, or +5. And this is 1. So 5, 1 is it. What else do you notice right away by looking at this particular equation? It's one of the key features, you know?
There's a 2 in the front, meaning it's going to be more narrow.
That's right, the 2 in front, leading coefficient is what we would term that, means it will be more narrow. Excellent, okay. Next one, y equals 1/2 x plus 3 squared plus 4. What do we get on that guy? Somebody who hasn't helped yet? Let's go, Evan. Good, the vertex is -3, 4. I like it. What else can you tell about this particular graph?
The leading coefficient is 1/2, so it's going to be wider.
That's right, leading coefficient of 1/2, it'll be wider. Nicely done. And last but not least, y equals -5 x plus 1 squared minus 2. AJ?
-1, -2.
-1, -2 is the
Vertex.
vertex. And what else can you tell?
It's going to be flipped upside down.
It's going to be upside down because of the
Negative.
negative. And will it be narrow or wide?
Narrow.
Narrow, very good, because of the 5. It'll be really narrow. Now, very quickly, I forgot to mention, what is the axis of symmetry for the first one? What is the axis of symmetry on the first one? We don't need the formula. Formula would not be good. You should be able to look at it and know. Kaylee?
5? Like x equals 5?
Yeah, see, I was actually hoping someone would screw it up, and you did, and then you caught yourself. It's, for the first one, it's x equals 5. It's extremely important that you understand that the axis of symmetry is a line. If you say the number 5, you're not naming a line. Furthermore, the axis of symmetry is always a vertical line, and any vertical line always begins x equals. and then you just pick the x coordinate. So what would be the axis of symmetry of the second one? Lipstick?
X equals -3.
Good. And what would the axis of symmetry of the last one be? Carissa? Come on, end the game. Axis of symmetry of the third one. All right, she was daydreaming. Somebody help her out. I want somebody who hasn't helped yet. Go ahead.
X equals -1.
That's right, x equals -1. Can you just give Carissa a quick heads up about why it has to be x equals -1?
Has to be x equals -1 because the point, because the axis of symmetry is the x point in the vertex.
Right, it'll always be on the x coordinate, because here's your vertex. So the x coordinate will stay the same, and any axis of symmetry always begins x equals. Okay, so we have that all lined up, we have it all marked up. And that can actually be used as a guide, not just for parabolas, but for any graph that's being done. So let's go to here, and it says, create the graphs of y equals x squared and y equals the square root of x on the same set of axes. So let's take some lines, draw them right down the middle. And to do these graphs, in all honesty, I would do them with your graphing calculator. So let's first graph y equals x squared. Okay, let's graph y is equal to x squared. You can just use your parabola, or I should say use your calculator, and look at the table, plot the points, pretty quick, pretty easy. Did everybody get my red parabola up here? Right, are we good? Okay. What do you think? Don't actually draw it, don't actually tell me what it is, but what do you think the parabola y equals x squared plus 4 would look like? What do you think y equals x squared plus 4 would look like? Cindy? Y equals x squared plus 4. What would be the difference between y equals x squared and y equals x squared plus 4? All right, I don't mean this, I'm not trying to sound snotty, but you're off your game because you should. All right, Ms. Rafferty, what would it be?
More narrow.
I'm sorry, what?
More
What did you say?
narrow. More narrow.
No, definitely not narrow. Narrow has to do with the number in front, the leading coefficient. Ms. Ford? Hi. Come on, y equals x squared plus 4. What would be the difference? This is a very straightforward thing here. Alexandria?
It'd be wider?
No. No, definitely not. Sari?
It'd be more up.
Yeah, it'd be up 4. This is your vertical shift. Remember? Y equals a times x minus h squared plus k. This is your vertical shift at the end. It slides it up 4. What if I asked you to draw y equals x squared minus 2? What would that do? Everybody? Down 2. What if I said, instead of this, I said this? What would that do?
It was moved over more?
Yes, left or right?
Left, mean right?
You had it right the first time. Left. It's always reversed in the parentheses.
Oh, okay.
Remember, horizontal shift, the h, because of that negative, it's always reversed in the parentheses. Okay? All right. So what would the vertex of this one be? There's two different shifts here. There's a horizontal shift and a vertical shift. What would the vertex of this one be? Evan?
It'd go 1 to the left and 5 down.
That's right. So the vertex would be -1, -5, or 1 to the left, 5 down. Now, on your calculator, leave this graph on there, and then I want you to do for y2, y equals the square root of x. You gotta do the square root button, and then you have to put in the x, and then you hit graph. And when you do it, you should get the green graph. Everybody agree? Okay, now, here's a really important question. I hope you're paying attention. I hope you're not just doing anything else. What do you think this would be? What do you think would be the effect of this? Janelle?
Will it be lower?
Yeah, it would lower it down too. It's still vertical shift. Vertical shift does not only apply to parabolas, it applies to all graphs. Isn't this also called the y-intercept with a line? Right? And doesn't it just move it down too? What about this one? What do you think that would be? In the game here. Anthony, what do you think?
Would it be steeper?
Definitely not steeper. Kaylee?
Does it bring it over to the left 5?
That's right, it would bring it to the left 5. 1, 2, 3, 4, 5. Here's my graph. It's, a radical acts as a parenthesis because it's grouping it. So as soon as it acts as a parenthesis, it's the same thing as up here with the H, and it means it's reversed and you gotta slide it whichever way you have to go. What do you think this would be? What?
How do you know which way? Whichever way is better.
It's always reversed in a parenthesis, it's always reversed in a grouping symbol. Okay?
So if it was 5 plus x, then it would
Ready? How would that shift? How many left and right? How many up and down? Lipstick, what do you think?
go to the left twice.
It will go to the left 2 and
Up 1.
up 1. Okay? All right. So the big point, the big reveal here is that we are still doing vertical and horizontal shift with other types of graphs. It doesn't only apply to a parabola. What do you think would happen if I put a 3 in front?
It would be more narrow.
It actually makes it wider because when I multiply by 3, I bring it up.
Oh, okay.
Does that make sense?
Yeah.
Okay? So I like to think of when you multiply by 3, coefficient of 3, it just makes it taller. And in the effect of a parabola, in making it taller, it makes it more narrow. But in the effect of a square root, it actually makes it wider. So it depends on the nature of the graph as to whether it gets more narrow or wider. Okay, let's go to the next page. And let's apply what we just learned and see that it works here. These are some absolutely massive numbers. What is negative 8 cubed? You can just use your calculator. Anytime we use an exponent, negative numbers, it's always wise to use parentheses. It just so happens it won't affect this one, but what do we get? It is 512. I thought it was negative 512. I wasn't sure. This works out to be negative 2. Negative 2 cubed is negative 8, and this works out to be the cube root of negative 2, which as a decimal, what does that work out to be? I don't even know. 1.2? 1.3? I don't even know.
1.25.
Negative 1.25?
Yeah.
Okay. Negative 1 cubed is negative 1, it's also negative 1, that's 0, that's 0, that's 1, that's 1, that's 8, that's 1.25, and this is gonna be 512, and this is gonna be 2. All right, so let me just do a sketch of a graph here. We're not going to actually do a graph. That was supposed to be black, but oh well. Oh, I'll do the graph in black, we'll reverse everything. All right, so if I went out to negative 8, I would be like way down here at negative 512. Then if I go to negative 2, I'm down here at about negative 8, which I'm just gonna say is there, I don't really know. -1 is -1.25. Would you get off the screen? I wanna hit you. All right, here, then 0, then here, then 2, 4, 6, 8, good. And then way there. So this is the graph of y equals x cubed. Can you put it on your calculator, please, and show yourself your graph of y equals x cubed? Are we good? Now, you know, this is kind of like, take a look here, ready? Isn't it kind of like we took this half of the parabola that would have went over here, and we took it and we folded it down here? Because with cubes, you can get negatives, right? You know how you can never square a number and get a negative? So the square stays positive up by these dotted ones over here. But with a cube, we can get negative, so we kind of just twist it here. This is called an inflection point, and we keep going down into the negatives. So that can happen. Now, what do you think this would be? What do you think that graph would look like? Y equals x plus 4 cubed. What would happen there? Sydney, shot at redemption.
It would go to the left 4.
Perfect. Y equals, go to the left 4, 1, 2, 3, 4. So we can do quick, these are called sketches, quick sketches of the graph. All right, what do you think this would be? What would happen here? Kyle?
It would go to the left 2 and up 5.
All right, the up 5 is right. We go to the right 2. Remember, it's always reversed in the parentheses. So 2, 2, 4, 5, and there's my graph. So we could sketch really, really quickly just by looking for horizontal and vertical shift. Okay, now in blue, I'm going to graph the cube root of x. The cube root of x is a little bit different than the square root of x. The cube root of x goes like that. Do you remember how the square root didn't have the piece on the left side of the y-axis? Because you can't get a negative square root. But you can get a negative cube root, and that's why the cube root goes out over to there. So what do you think this would be? What would happen here? Got some more horizontal and vertical shift going on. Ms. Sayers?
It would go to the left 4 and down 1.
We'll go to the left 4. 1, 2, 3, 4, down 1, and then it would look pretty much the same. Okay? And those are quick sketches. So what we've really emphasized a lot over the last 2 days is vertical and horizontal shift. If it's in the grouping symbol, you reverse it. And if it's at the end, it's up or down, just keep the sign the same. And then if you put a lead coefficient, it has an effect on it. In effect, the best way to explain it is it makes it taller if it's a number greater than 1, which in the effect of a parabola will make it more narrow, but in the effect of a square root or a cube root will actually make it wider, okay? So understand the nature of all of those things. If you put a lead coefficient less than 1 in a parabola, it would make it wider. Now, I have never seen them on the Regents ask about a square root with a coefficient other than 1 or a cube root. They've never asked that. They've only asked about parabolas. But I do want you to be aware that it's not as simple as saying a number greater than 1 is going to make it more narrow. It depends on the graph. Okay? Any questions? All right, you may begin and your homework. Hopefully you can get it done before you leave for your vacation. Spencer, can you hit the lights, bud? Thank you.